So this set of videos is going to concern sections 1.1 to 1.2. Oops. And what they're going to be is about sort of basics that we need to know about ordinary differential equations and initial value problems. That's a little bit of abbreviation up there that's going to make sense as we work through these videos. Before we launch into the content, what I'd like to do is kind of set the stage for what we're going to be learning. So I'm going to list right here what you should get out of this set of videos so that at the end of the videos, if you haven't gotten those things yet, you sort of know where to start asking questions. So what we're going to do is we're going to talk about the basics, ideas of differential equations. What that's going to include is sort of intuition about what these mean. And then important vocabulary. For talking about them. The reason for this is because this is a class about solving differential equations. So before you launch into that, you need to know what they are, why you might want to solve them. And then we all have to have the same set of words to talk about them so that when I tell you about a particular type of problem or method that you're going to use, you know exactly where to fit it into this broader framework of differential equations. After we do that, we're going to talk about and differential equations are going to be that abbreviation ODEs. After that, we'll talk about basic ideas of initial value problems. That's going to be that IVPs that I said this is second topic of the videos. And so that's going to also come down to two different things. The first is going to be just sort of the idea of solving algebraically. One of those initial value problems. We'll talk about why you want to do that and sort of why we think about this additional type of problem every time we talk about differential equations. And then sort of, I think the hardest thing we're going to do in this section is going to be using the initial value problem theorem. So it's not super tricky, but it comes up again later in class. And the notation, I think, can throw people off a little bit. So I would say that if there's something to watch for in this section, it's going to be that. And then after those two sort of primary goals, one other thing that you should be getting out of this video, well, this set of videos, is sort of becoming familiar with our classroom style. So that's going to be flipped learning, specifically what it means in our class. So sort of this idea that you'll watch this set of videos on your own and then be able to come into class with questions to ask me. So just sort of learning how to operate that way is something that I hope this kind of easy introduction to differential equations will give you a chance to also practice those skills. So I'm going to launch into that first bit of introduction, and we might stop halfway through just so that I can cut us off at about every 10 minutes because I'd like you to be able to take breaks in between these videos. So we will see how far we get before we have to take a quick break. So the first thing we're going to talk about is an introduction to differential equations. I'm going to use these squiggly lines. They make it look a little bit better the way I write. So at its most basic, a differential equation is an equation that uses derivatives. So So that's something that you could kind of conclude from the word differential equation. It must be an equation. And then the word differential means concerning derivatives. So a differential equation is an equation that uses derivatives. So the example that we're going to talk about for a little bit here is going to be the equation du dx is equal to 3 times u. That's an equation, has an equal sign in it. It has a derivative in it, du dx, so it's a differential equation. And the way I'm going to abbreviate differential equation is going to be ODE or DE if I'm being especially lazy. And the first thing you'd sort of wonder is where this type of thing comes from. So, for example, if instead of writing that equation, du dx equal to 3u, if you were given u of x is equal to 7 e to the 3x, then just using your basic calculus knowledge, you could say, okay, du dx is the derivative of u with respect to x, so that's going to be 3 times 7 e to the 3x, just using like your exponential rule. But since 7 e to the 3x is what u was, that's actually just 3 times u, if you make that substitution from the definition of what u was. And so all this equation is saying to us is that the derivative of u is 3 times u. And we'd sort of wonder eventually why we want to be able to write this type of equation, but for now we're just going to wrap our heads around what it means and when it might arise and what we would do with it. So this whole class is going to be about solving differential equations. I gave you your first differential equation right here, and because we found it using your basic calculus knowledge right here, we can already say that this is an equation we know how to solve. Specifically, a solution to this ODE is u of x equal to 7 e to the 3x. But that 7 wasn't really special. So really, you could have or u of x equal to 7,000 e to the 3x would still satisfy that exact same equation. Or even u of x equal to 0. So the derivative of 0 with respect to x is 0. 0 is the same as 3 times 0, so it satisfies the differential equation. This whole class is going to be about this part right here, where you have an equation and you try to solve it, and you run into this problem that there's a whole lot of different ways that you could possibly do that. So it looks like we have a couple minutes, so I'm going to sort of launch us into a little bit of vocab, but we'll probably stop partway through this slide. So throughout this class, we're going to use a little bit of vocabulary to talk about the important parts of a differential equation. So you'll probably still be familiar with these from other classes, but just in case, I'd like to touch on them real quick. So independent variables, and we're going to say that those are things like t or x, are things that we input to functions, which describe dependent variables, like u or y. You could even think about, depending on like how you think about things, y could be an independent variable, like a way to define space, but when we see it in this class, it'll usually be an independent variable, so I just want to have that here to start. We represent these relationships by something like u of t or y of x. You could even have u of x or y of t, just depends on what your independent variable is and what your dependent variable is. I'm going to pause right here so that you can take a break if you need to, depending on how long you can focus before you need to step away. So click on through for the next video whenever you're ready.